Konnichiwa minna. Hello everyone, my name is Mackenzie. I am a developer and security advocate at GitGuardian, and I'd like to welcome you to this webinar, to this session, where we're going to be discussing some of the latest research that we've done at GitGuardian, which relates to Secrets Sprawl and discovering secrets, which we'll talk about what they are, in lots of different public places. So without further ado, I'd like to get straight into the presentation. So this presentation is titled The State of Secrets Sprawl 2023, and it relates to a report of the exact same name. And we're going to run through how we discovered millions of secrets and other credentials in public spaces. So to start with a little bit of context, every year GitGuardian releases a report called The State of Secrets Sprawl, and that report looks into discovering what we call secrets in lots of different areas and public spaces on the internet, but mainly inside source code. So a good place to start, obviously, is what are secrets? When I'm talking about secrets, I'm referring to digital authentication credentials, and this is anything that authenticates us to different services or systems. So typically these are things like your API keys, maybe credential peers, database credentials, FTP credentials, security certificates, or anything that allows us to authenticate, connect, decrypt, or digest information. And what's key to understand here is that these credentials are made to be used programmatically, which means they're meant to be used from other machines. This is really machine-to-machine communication. And this is significant because these often end up inside our source code. And our source code, as I will explain, is a very leaky asset. So let's have a quick rundown at how we use secrets. So we no longer build these monolithic applications, right? Modern applications are built up of lots of different services. So as an example, we might be using Okta for authentication. We might be using Algolia for search functionality. We might be using Stripe for payment systems or anything else. All of these systems are great because it allows us to really focus on what we're building and not worry about different systems and services that aren't integral to what makes our application unique and important. But each one of these logos represents a vulnerability because they all use secrets. And if an attacker can gain access to those secrets, they can move into your infrastructure and potentially keep moving laterally. But it's not just our application. Obviously, we need to host and service our applications now. So we have cloud infrastructure keys. We might be using GitHub or another kind of version control system. They use authentication tokens. We have our CI/CD pipelines, which use authentication. So again, we have lots more secrets. Once our application is running, we have marketing teams, obviously, that want visibility and dashboards and interconnections into their systems, so that's more secrets. And of course, we're building our own systems. Again, much more secrets. So you can see how an application can quickly become really a collection of these different building blocks, and secrets, API keys, are what tie them all together. So that's it for a quick rundown of what are secrets and how we use them. I'm going to spend the rest of the presentation really talking about the research that we've done and the results that we found. So what did we find in our report for the state of Secrets Sprawl in 2023? One of the main places that we really look for secrets is this website here, which is github.com. GitHub is the largest code sharing platform on the planet. It has millions and millions of users, and it has huge amounts of public source code. What's interesting about GitHub is that even if your organization is not using GitHub, it is very likely that your developers are. And that is because they have their own projects, they may use it as a learning tool, they may be contributing to open source projects, and most importantly, they may be using GitHub as a portfolio for their work, which is often exactly what developers do. So it's very likely that your developers, your software engineers are already using GitHub. And with that in mind, we're going to look at exactly what we found, how many secrets we found on GitHub, and how this could potentially relate to your organization as a risk. So some stats on GitHub to start with. It's massive. There's 94 million developers that use GitHub. And last year, over 1 billion commits. A commit can be considered a contribution or, uploading source code to the GitHub public ledger. So over 1 billion commits of source code were made last year. So it's a huge amount of data. 85 million new repositories were made. And all of this is just public, right? We're not talking about what's happening privately behind authentication. We're talking about what is happening publicly on GitHub. So huge amounts of data that is going through there. With GitGuardian, what we did is we actually scanned all of this information. So that 1 billion commits, we scanned it all for secrets to try and identify if secrets are leaking out in the public sphere. So what did we find? We found a lot. This year we found 10 million secrets. This is about a 67% increase on previous years, and I'll show the progression through that. And again, this is just publicly. This is secrets that we've found out there in the public that anyone can access. So Secrets Sprawl, as we call it, is really getting worse. The first year we released this report was in 2020, and we've discovered 3 million secrets. The first year we released this report was actually in 2021, and I was looking at the year 2020. 3 million secrets were leaked that year. It doubled the next year to 6 million, and it increased again this year to 10 million. So what really explains this massive increase? It can be explained by a couple of things. Firstly, the amount of users using GitHub and pushing source code publicly increases each year as the user base expands. But it increases by about 20%, so it doesn't explain fully the jump. It also can be explained partially by GitGuardian getting better. We retrain our algorithms on all the data that we find, so every year we get better and more accurate. So again, that increases it a little bit, but definitely not as much as what we've seen. So if we look at kind of the closest thing that we can do to an apples to apples comparison, and that is that we find about 5.5 secrets, let's call it 6 secrets per 1,000 commits made publicly on GitHub. This is a 50% increase to what we were discovering on a per commit basis last year. So with the same amount of code, we're finding 50% more secrets. Some of this is also because the attack surface is really expanding. We used to just have applications on GitHub, and that was all that we really needed to worry about, our software. But now we've really codified lots of elements. Infrastructure as code has become really popular, but that means that our infrastructure is being written in source code and probably version controlled and potentially open sourced to help others or to keep track of it. This infrastructure as code is containing secrets. So the attack surface is really expanding. We're using secrets in more and more ways. This is what really explains the increase. The scariest number that I have in this report is the 1 in 10. So 1 in 10 authors actually exposed a secret in 2022. So you may think that this is just some junior developers. No, actually it's a lot more than that. So 14 million developers pushed code publicly last year. In my previous slides, I said that there was 94 million developers on GitHub. Yes, that is true, but 14 million of them actually pushed and contributed code publicly last year. 1 in 10 of them leaked a secret. That is a huge amount of developers. It throws cold water on the idea that this is just a problem with junior developers. It's actually a problem everywhere. And when we look into it, we can actually see that advanced developers, senior developers are leaking secrets at almost the exact same rate as everyone else. And they also have more access to secrets. So this makes sense also. We can have a look at the countries that are leaking the most amount of secrets. And this is kind of interesting because it shows it's a worldwide problem. However, I don't like to look too much into this results. If we look at the top 3 results, India, China, and the USA, what do they all have in common? They have large populations with a lot of software engineers. So really, it's in line with their engineering population. The reason why China isn't number 1 is simply because they have their own tools along with GitHub that they use specifically in China, which means that not all Chinese developers are exposed to GitHub. But basically, this just shows it is a worldwide problem. And what this graph doesn't show is that India or China or USA is specifically worse than any other country. It's just showing that, hey, it's a global problem. It happens to every country and no one is immune from it. Now, what about the types of secrets that we find? So at GitGuardian, we have a unique way of discovering secrets. We have individual detectors to try and find them. So we have over 300 detectors, and each one of these detectors is looking for really a specific secret. And then we also have generic detectors that catch all the rest of them. And this means that we have a lot of accuracy in what we find, but it also means that we can actually look at kind of the areas of where we find them. So obviously there's a lot of different types of secrets that are used for all kinds of things. So other really encompasses anything that's not on this graph, and obviously that is the biggest. But close second is data storage. So this could be things like database credentials, it could be S3 buckets. This is really makes up nearly 25% of the secrets that we find. So really 2.5 million database credentials were leaked. So these could be for lots of different things. I'm going to show you an example of a Japanese company that did have a database credential leaked in public GitHub. The next thing that there is cloud providers. So 2 million, 20% cloud provider keys were leaked. This one's really interesting. We validate a lot of our secrets. Cloud providers are one of them. That means that we're only finding secrets that not only fit the criteria of that secret, but are also actually valid right now. They gain access to something. 2 million cloud provider keys were leaked last year. You don't need to be a malicious genius to really understand what you can do with a cloud provider key. At the very least, you could mine some crypto. You could use the infrastructure to divert malicious attacks into different areas. You can shut down services. Really, you can do so much. You can squat inside systems. There's a lot of cloud provider keys out there. If you're an attacker, you probably never have to actually pay for any cloud provider services because there's so many keys that you can use sitting out there in public spaces. Other significant ones, we have messaging systems, private keys, and my personal favorite, version control platforms. What this means is that you've leaked the keys to your private GitHub publicly. We can also look at the specific detectors that are picking up the most amount of secrets. So number one is the Google API key. Number two is our RSA private keys. And also we have some pretty scary ones up there. Google Cloud keys and AWS keys make a significant portion of what we actually find. These are highly sensitive. We also find a lot of GitHub access tokens, and this is exactly what I was talking about. The private access to your private repositories that you've pushed publicly, and lots more. Obviously, we have a very long tail. We have hundreds and hundreds of different categories and different secrets we're looking for, so we can't fit them all on here, but there's a bit more information in the report that I'll share at the end. So let's look at some examples of where this has actually affected organizations. Now, there is a lot of examples that I can call on of when secrets have been leaked publicly, discovered by malicious actors, and found them. Uber has had a number of cases. SolarWinds has had some cases. But in this one, I'm going to look at a recent leak, recently discovered leak that was done that involved Toyota. So let's have a look at this here. So what actually happened? Well, this relates to a service that Toyota was using, a mobile application called T-Connect. It was for some specific services that related to Toyota customers, people that owned Toyota cars. To develop this application, Toyota engaged a third-party contractor that helped build and maintain this technology. What actually happened is that in 2017, this contractor, not Toyota, this contractor accidentally leaked source code that was meant to be private in a public repository. It sat there for 5 years. What were those credentials? They were credentials that gave access to the entire customer database that of everyone that was using the T-Connect application. I think there was a couple of 100,000 users in there. A third party was actually able to find that credential and validate it. In this case, it was our security researcher who alerted Toyota to it, and the key was obviously revoked. But we don't know in the 5 years if anyone else was actually able to access that. That's a lot of logs, a lot of access to sift through, 5 years of logs to try and find out if someone had accessed that. I think it's a fair assumption to say that we'd need to consider that that information has been accessed by a third party, a malicious third party. So this is actually an interesting situation because it shows that perhaps Toyota themselves didn't have any coverage to GitHub. And therefore, they probably weren't aware of it as part of their attack surface. However, a contractor was using GitHub, or perhaps it was even just a single software engineer of that contractor that was using GitHub. Maybe they accidentally pushed it to the wrong place. Perhaps they made a repository public that was meant to be private. There's a number of scenarios that it could have been, but the end result is the same. Keys were leaked on public GitHub. So how would someone actually find these keys? There's some interesting ways to do it. The most obvious, easiest way, and one that I didn't really like because for some reasons, is to really just use GitHub search feature. So in this case, we're doing a search for a file called credentials that has what is in it, the variable AWS access key ID. And we're searching through GitHub. Now we have 18,000 results here. It's going to take a lot of sifting to actually find a real one, but they will be there. The reason why this isn't really that effective is because this isn't looking at all the history. It's only looking at the latest versions of it. And most of the secrets that we find in version control are in previous versions of that history. There's lots of different types of searches that you can do for specific keywords, and you will definitely find some. There's enough information out there. But there's actually a better way of being able to discover sensitive information. And I show this just to illustrate how easy it is for a malicious actor to do this. This here is the GitHub API. This is their public events API. You can view this yourself. You don't even need authentication. You can simply go to api.github.com/events. And once you're there, you will see a complete ledger of everything that is happening on GitHub, including the metadata. So we can see the GitHub user, we can see their email address, we can see what they're pushing and where they're pushing it to. So we can monitor this. We can actually monitor specific people if we're really targeting organizations and we know that they work for Toyota or other organizations. There's a lot of events that are published here, but the two that an attacker will be after are the public event. This is when a private repository is made public, and also the push event. This is when we're pushing code publicly. So if you monitor these, as I said, we found 10 million secrets through the public API last year. And this will also allow you to not just look at that surface level. It allows you to look at real time at all of the events that are happening. And this is basically how you can discover sensitive information on GitHub by abusing the GitHub API. So this is really a big problem. And really, it's not an obscure example. It really does happen. And attackers are monitoring this for malicious purposes. But I also want to pivot now away from public repositories and into private repositories, because the problem is much worse when we're talking about private infrastructure. So at GitGuardian, we can scan the internal infrastructure to discover secrets, and specifically the internal version control, private version control systems. What we will typically find is in a small but kind of average, medium-sized organization, they might have about 400 developers. We obviously have customers with a lot more and some with a little bit less. But if we take just an average size company of 400 developers, what we will typically find is about 1,050 unique valid credentials in their private source code. So that's quite a lot. What we will also find is that each of those secrets will occur about 13 times. So the total amount of secrets that we discover is about 13,000. Because once a secret leaks into version control, it sprawls into multiple different places. Now, in that same company, they'll have about 4 AppSec engineers. 1 AppSec engineer per 100 developers really seems to be the industry standard. But this is a pretty big problem, because now that AppSec engineer has 13,000 secrets that they need to investigate. So what do they need to do? They need to find and communicate with the person that leaked it, because they need to know what this key does. They need to know, is it valid? They need to know what it gives access to, and is it a potential risk? Once they've figured out that, they need to revoke that credential and issue a new key, but they need to do that without causing any kind of downtime. So that's a bit of a tricky situation. And then they need to redeploy the application. They need to do that 13,000 times between 4 of them. That's 3,413 times each. If that's your only job, and it's not, but if that is, it would still take you the entire year with no holidays to resolve this. So this is why internal infrastructure is really just much worse than what we see in the public. And it's very, very critical that secrets don't end up in there, because even if you say that it's private, you need authentication. Source code is notoriously leaky. I'll show you examples in a minute of when source code has leaked and how it has leaked. But basically, if you have secrets inside your source code, such as in these examples, then they're going to end up in unsecure places, and all of your developers that have access to the source code now have access to the secrets. So last year we saw lots and lots of source code leakages from massive companies. NVIDIA, Samsung, Microsoft, LastPass, Dropbox, Okta, Slack, all had significant amounts of their source code leaked publicly, or as I like to call it, involuntarily open sourced. So how did this happen? How did these companies, all of which I would consider great companies with very good security posture, how did their source code get leaked? Well, it can happen in a couple of different ways. A lot of the examples here, they were leaked by a hacking group called Lapsus. How did Lapsus gain access to them? To put it simply, they purchased access. They either bought credentials from the dark web that had been obtained by other nefarious actors, or they paid employees of these companies directly. In their Telegram channel, there was plenty of recruitment messages to try and find people that worked in these companies and offer them a few $1,000s to give them access. So imagine you're a software engineer, you've potentially had a bad day, you need some money, and someone is offering you a couple of $1,000s just to give access to source code. Well, it's definitely going to happen. And this is why, it's a risk. And we shouldn't be paralyzed by this risk and be suspicious of all our employees. What we need to do is understand that source code shouldn't be a security vulnerability. If our source code leaks, it can be a problem, but it shouldn't create massive security issues. And one way we can do that is by removing secrets. Other ways that source code have leaked is just through misconfigurations. Twitch's source code, all of it was leaked because someone updated the configuration of their Git server and accidentally just made everything public. A nefarious actor found it and leaked it. These mistakes can happen. Source code is also probably backed up into different areas and is cloned onto lots of developers' machines. It's shared in wikis and in messaging systems, so we really can't guarantee that it's locked down. Worst of all, source code has absolutely no logs to let us know who's accessed it or where it is. So we really need to make sure that our secrets are not in our internal infrastructure in our source code. So are there some breaches that we can look at of where this has happened? Absolutely. I'm going to start with probably the biggest one of last year, which was the Uber breach. This one was a bit of a doozy. What actually happened? So again, this involves not the Lapsus group, but a member of the Lapsus group. They purchased access to Uber's internal network via credentials for a VPN. Now, this VPN had multi-factor authentication on it, so the attack should have stopped there. Except this attacker was persistent. They spammed the multi-factor authentication and called the user pretending to be the security team, and eventually they were granted access into Uber's internal network. The first thing they did was start scanning that network to try and find credentials. Basically allow them to persist access. Right now, their access is based off a single user's VPN. If that's reset, then they could lose their access. So they want to try and make sure they have additional ways of access. Secrets are the number one way of doing that. They actually found some secrets inside some PowerShell scripts. And these PowerShell scripts did a specific job. They were used by the admins to create accounts when a new employee would join. So to understand how this worked, we have to look at a different system that Uber was using. It was a system called Thycotic, and it was a PAM system, a Privileged Access Management System. You can consider this a password manager and a secrets manager rolled into one product. It's extremely sensitive. So this contained really the credentials and had the ability to create accounts on behalf of Uber's admins. So what did this PowerShell script did? When a new employee would come to the organization, they would run this PowerShell script and it would create accounts for that new employee. So what do you think the attackers did when they got access to the credentials in this script? They created themselves accounts in all of Uber's systems. This included AWS, GCP, Google Drive, Slack, SentinelOne, even their HackerOne accounts, and many, many more. Basically, they had complete access into all of Uber's infrastructure. So this is pretty much the worst case scenario. Now, in this case, the attacker was really after clout. They wanted notoriety. So they actually didn't really do anything too nefarious at once they were on there. They leaked out some information, they posted in the Slack channel, they immediately let Uber know that they had been breached. But had they been more malicious, they could have sold access into Uber's systems to people that were after much more nefarious intentions. We can look at another one here. This is another kind of worst case scenario. This one's interesting because it shows movement through secrets on multiple levels. CodeCov is a code coverage tool. It does a specific thing. It sits in the CI/CD pipelines and it measures how much of your application is being tested during the testing phase. So it tests how much of your software is being tested. It's a great company, it's a cool product, but they made a mistake. One of the ways that you use CodeCov is via their container, their official container, which was a Docker image, and it was hosted publicly. Anyone could download this Docker image and deploy CodeCov. Inside this Docker image was a hard-coded credential. This credential had read-write access to some source code. It was actually hosted in Google Drive, and it was a bash uploader script. The attackers were able to alter this bash uploader script and inject some malicious code. What did that malicious code do? It was just one line, and it essentially said, every time CodeCov is running, I want you to dump all the environment variables, so all the secrets, and I want you to send them to me. So that means that the attacker were getting sent lots of secrets every time someone from CodeCov was using their tool. And CodeCov at the time had 20,000 large organizations that were using it. The attackers were specifically after one thing, and that is Git access tokens, the version control tokens. We had talked about these in the public section. Once they had access to these GitHub tokens, they were able to move laterally into the private Git repositories of different organizations. Via CodeCov's Docker image, attackers were able to move into different organizations' private infrastructure. Some of the organizations they exploited were Monday.com, Rapid7, HashiCorp, and many, many more. A lot of those companies that I just mentioned had to release public statements saying that there was a security incident because they had secrets in those private repositories that now a nefarious actor had access to. That also included HashiCorp, which created a product called HashiCorp Vault, which is a secrets manager. And I always like to say that if HashiCorp has secrets inside their private repositories, then there's probably no hope for any other organization. The report also looks at a new trend. Back in the start, we're just focusing on secrets that we're finding. But I also said the reason why the secrets are expanding is because we're moving into different areas, such as infrastructure as code. So not only are we discovering secrets in infrastructure as code, we're actually discovering that there's a lot of vulnerabilities in the infrastructure as code that is on public GitHub. In fact, we've estimated based on our research that around about 21.5%, we'll call it 22%, of infrastructure as code repositories that relating to Terraform have pretty significant vulnerabilities inside them. So these vulnerabilities could be things like not using HTTPS, using HTTP. They could be exposing information like S3 buckets. So we've all read in the news how organization has leaked public information because the S3 buckets are publicly accessible. Well, this is how that happens. It's because you have misconfigurations and vulnerabilities in your infrastructure as code. So we've found lots and lots of vulnerabilities in these infrastructure as code repositories. So this is really becoming another attack surface. I also said that the reason why Twitch's source code was leaked publicly was actually because they had misconfigured Git server. Well, guess how that Git server was misconfigured? Yes, through infrastructure as code. So this introduces kind of a new element to our reporting this year. And we're starting to really offer that solution of being able to not only scan your infrastructure for secrets, but also be able to scan your infrastructure as code for misconfigurations to make sure that you don't have access granted to things that really should be locked down. So how does this actually happen? How do secrets get exposed? Well, this happens in a lot of ways. Some of you are probably sitting here thinking, yes, but we have great developers, we have good code checking system set up, no one's going to leak a secret in our organization. Well, I can almost guarantee that it does happen, and it happens for lots of reasons. One of the reasons for leaking secrets is when they're committed when you're testing something. Version control is interesting and difficult because it maintains a log of everything that's happened. If we think about our repository, I've asked a developer to create a new feature. Let's say that I want them to connect up to this database and print out some information from it. The first thing I'm going to do is create a new branch so I can work on my feature without it affecting anything else. Because I want to move quickly, I'm just going to hard code the database credentials just to see if I can get information. Once I have that working, maybe I'll remove them. I'll use environment variables or other secure ways of managing it. Once that feature is finished, I'll do a merge request or a pull request, and the reviewer will look at the code, but they're not going to look at the entire history. They're going to be looking at just the latest versions. 100 commits down the line, that developer hard-coded a secret, but it's now impossible to see. That secret is now in the repository and no one knows that it's there. That's one very common way that secrets get in repositories. They also could be that private repositories are made public. Don't forget that just because you're turning a private repository public, that you're not also making public all the history. Something that happened a year ago on a private repository is now public. We also see lots of secrets printed in log files, like debug logs. These debug logs will often contain environment variables. And if we have got environment variables in our logs, then that's secrets. We can add them to our Git repositories by accident by doing git add all, for example, and now we have secrets in our repositories. Secrets are in sensitive files. The number one file we found secrets in was the .env file. So this is also a big risk, and it often ends up inside Git repositories. And the way that we often see is when we push code to the wrong repositories. In GitHub, for example, we often have one account for both professional and personal use. It makes it very easy to accidentally push code to the wrong place. May not think that it happens often, but it does happen enough that it is a significant risk. How can you prevent this? Well, there are a few ways that we can do this. One, we need to assume that we're going to be breached. Not because we're saying that it's impossible that we're not going to, but because once we adopt that mindset of assuming that we're going to be breached, then we change the way we think about it. We can threat model what happens if an attacker gains access to our systems. Are there secrets in there? Where can they move laterally? How can we segment our services? Once we assume that we're going to be breached, then we need to move on to the next step, which is very obvious, and that's to find out where we have secrets. This is the first thing that an attacker is going to look for to persist their access and to try and elevate their privileges. So we can use secrets detection automatically to make sure we don't have secrets in our systems. And that's a very important step. Once we've kind of moved into that area, we can actually start adding some additional security measures. For instance, zero trust, which is basically saying that, hey, just because we have an API key doesn't mean that everything with that key should be able to access it. If a specific system is meant to connect to another specific system with that key, then we can limit that access just to a specific IP address range and really make sure that we trust that machine, not just the API key. So that's another area. And another important part of that is to use short-lived credentials. We should have a policy of rotating and updating our secrets very regularly. Obviously, this has the benefit that if one gets leaked, it won't remain valid forever. But it also has the additional benefit of the fact that we actually know how to rotate secrets if we're doing it regularly. Another element that is really helpful is to use honey tokens to identify when you have breaches. One of the problems is that when an attacker breaks into your systems or gets into your source code, you often won't find out immediately because they're not making noise initially. You will find out when they're ready to kind of launch their attack. Honey tokens are decoy credentials that when an attacker uses them, just alerts you to their presence. They're very simple, but very effective way of knowing when an attacker has breached your system. And once you can use those, you can add additional steps when a breach has occurred. It also is a great way of honey tokens to know when your source code has leaked, because if your source code leaks publicly with honey tokens, immediately someone's going to try and find them and use them. So then you're going to know when your source code has leaked. Number 5 is segment your development environment. This just means don't use the same secrets for production as your testing or development environments. And also make sure you're using infrastructure as code and infrastructure as code scanning to identify vulnerabilities. So this is just some ideas of how we can increase the level of security that we have and preventing these secrets from leaking. There's much more that we can do. Secrets managers, dynamic secrets, other areas, but it's really specific to your organization. So these tips are much more general and broad. So that's the end of the presentation. I do hope that you enjoyed it. The full report, the full State of Secrets report, is available to you, and I'm sure that there'll be links to it. I'd now like to hand over to my colleague, Ramzi, who's going to give a demonstration of the GitGuardian product and how it can fit into helping prevent secret sprawl. So I'll hand it over to him.